Hi student, thank you for joining my class today. So we're going to look at our last topic for today called parametric equation. So how many of you heard about parametric equation? So obviously it involving curve or any particle that move along a curve. So if I have a diagram here, let's say this is my x and y. And I have this curve, let's see, something like this. Okay, this curve here, the direction, let's say from here, and there is a point, x and y, which is refer to the point of my function given at t and gt. So this curve here, we can describe this curve C by an equation in the form of y equals to fx. Okay, so but x and y coordinate are function in time. Because it's function in time, we can say that x equals to ft and y equals to gt. Such a pair, this is a pair of equation, is often a convenient way of describing a curve. Okay, so we can say that a parametric equation is given by these two functions here. X equals to ft, y equals to gt. These are called parametric equations. Each value of t determines the point at x and y, which we can plot in a coordinate plane. Okay, and C here is called the parametric curve. The parameter t does not necessarily represent time, but in many applications of parametric curve, t does denote time. In this, we can say that t is a position of a particle at time t. Okay, so what simple example I can give you is something like this. Okay, so the question say sketch and identify the curve defined by these equations. Okay, so what are the equations? Let's look at what are the equations. So we have x equals to t squared minus 2t and y equals to t plus 1. Now this equation is also called parametric equation because we have x in t and y in t, two equations, right? So to sketch this, whatever knowledge about graphing that you have learned, okay, you can do that easily. So what I do, I draw a table, which will be easier if you sketch a table for this. So we have t, we have equation for x, which is x equals to t squared minus 2t, and then y equals to t plus 1. Okay, so now what we want to do here, because it didn't give you the interval x, so start with a negative number and then start with a positive number. So you can start with -2, -1, 0, 1, 2, and then add on more points if your graph is not that smooth. Okay, so when t is -2, this is 2 squared minus with positive, so 4 plus 4, which is 8. This one will be 3. -2 plus 1 is -1. When this is -1, it will be 1 plus 2, which is 3. This will be -1 plus 1, 0. When this is 0, this will be 0. When this is 0, this will be 1. When this is 1, this will be -1. When this is 1, this will be 2. And then when this is 2, similar with -2, but then here you have Oh, this will be 4 minus 4, so 0. Wow, and then this will be 2 plus 1, 3. Okay, so these are some of the points we got. Now let's try to sketch it. Okay, so it's a sketch and identify the curve. Okay, so we're going to sketch it with all the information we have obtained, the point. So we have, this is a 0 here. Remember, these are your x and y points, okay? So we have 0, minus 1. And then we have 1, 2, 3, 4. I have to do until 8. So, and just sketch it further. Small it for you. Okay. That's just a sketch. 5, 6, 7, let's say 8 here. Okay. And then you have here 1 and minus 1. And then we have, let's do 2 and 2. Although, yeah, we have 2 here and 3 as well. So you need another. So I hope you know how to sketch this based on your x and y values that you obtain. Okay, you have up to 3, right? So let me just do up to 3. Okay, so when this is 8 minus 1, minus 1, 8, I have a point here. And then when x is 3, my y is 0. Okay, that's nice. When x is 0, my y is 1. And then when x is minus 1, y is 2. So it should be like here, somewhere here. Okay, when x is minus 1, y is 2. Now back to when it's 0 is 3. Oh, I think so if I can connect this curve, it'll be something like this. Okay, so you can go furthermore, and just to see the shape of this curve, you can go furthermore. Let's say this is 3 and 4. So 3 squared, 9 minus 6. So 3 plus 1, 4. And when it's 4, 16 minus 8 is 8. 4 plus 1, 5. Okay, let's add 2 more. When this is 3, you have 4. Let's say my 4 is here. When x, this will be 8. This is somewhere here. So you can see that this is the curve that you got from the sketch here. Okay, so why we can see that for each value of t, the points of the curves is given in this table here that you have sketched. And the graph, this is a graph of the curve that given. So a particle whose position is given by the parametric equation moves. So it moves along the direction. Start from here, 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 here. Along the curve in the direction of the arrows as t increases. Okay. So if we substitute, now this is we want to identify the curve now. So let's say t equals to y minus 1 from the second equation to the first equation. So this is the second equation, right? So t equals to y minus 1. Substitute into this first equation. What do you get? So we have x equals to y minus 1 squared minus 2t. Okay, oops, sorry, t is y minus 1. I have to substitute t equals to y minus 1. Okay, so simplifying this, y squared minus 2y plus 1 minus 2y plus 2. That will give me this equation. Y squared minus 4y plus 3. So the curve represented by the given parametric equation is the parabola. So this is the parabola equation that you have obtained. Okay, so what we can say here a few things. So a curve with the parametric equation x equals to ft and y equals to gt. So given from this interval a to b has the initial point. So the initial point is given at f of a, g of a, and terminal point at f of b, g of b. Okay, so this is a note here that I'm just going to put a note that you need to know. Okay, so it means that my initial points start at here. So my interval is, you can see that the interval for my t is -2 to 4, right? So this is my A, this is my B. So this will be my initial point. And the last one, no, not this one, further up. Okay, this is my terminal point. Okay, so that's the given equation here. So you have given two equation involving f and g. Okay, so this is how you sketch a parametric equation. If you're giving any function, you should be able to sketch them. Okay, and determine how the curve move. Okay, now let's look at different example than sketching. Now the technique that we have shown here is also called eliminating the parameter. Okay, so you eliminate the parameter from the set of parametric equation by writing one of the given function in terms of t and then substitute to the other function. Okay, so remember that that's how you can do it to obtain the equation involving x and y. Now in this topic, you can also learn something about tangent to the curve, which is we're going to look at now next video. Okay, so let's look at the tangent to the curve. That's our second part here. Now, what is the equation to find the tangent? So dy dx equals to m. Usually we put a m here for dy dx, right? So this is I don't want to put m here. So to find the tangent to a part, we just focus on the parametric curve here. So remember we have two equations involving x and y, x and y, right? So by using some chain rule, we can find the tangent to the curve. dy dt multiply with dt dx. So this is what we're going to use to find the tangent, equation of the tangent for the curve. Okay, so let's look at one example. So this is the very simple example. Find the tangent line to the parametrics curve given by, okay, so we have x equals to t to the power 5 minus 4t to the power 3 and y equals to t squared. So let's give the point at 0.04. Okay, so we have this two equation. Of course, this is parametric equation because we have term involving x equals to, this is our f of t, and y equals to, this is our g of t. Okay, let's find the parametric, find the derivative. Okay, so to find the derivative, we know that find the derivative of x, so with respect to t. t to the power 5 minus 4t cubed. So dx dt is 5t to the power 4 minus 12t squared. And for this one, dy dt equals to 2t. Okay, now taking the derivative, what we have? Dy dx equals to dy dt multiplied with dt over dx. So you have to swap dx dt to 1 over 5t to the power 4. Okay, so I have 2t multiplied with 1 over 5t to the power 4 minus 12t squared, which gives me dy dx equals to 2t over 5t to the power 4 minus 12t squared. Now, can I cancel out t? Yes, I can cancel out one of the t here. That will be 2. Or let's in a way to do it properly, let's factor t out so you can see how the cancellation occurs. Minus 12t. Okay, so you can see that this and this cancels out. That will give you 2 over 5/3 cubed minus 12t. Okay, so this is what we get, the equation, okay, the derivative for the tangent, the first derivative. Okay, now what we do next is you want to find the tangent line. Okay, the tangent line. So I need to look at the question again. Yeah, the tangent line. So if our equation is, okay, the tangent lines, meaning that the equation, so the tangent line. Okay, so now what we want to do here, okay, so let's we are given the points. We're given a point here 0, 4, where this is x and this is y. So let's look at the x first. Okay, so when x is 0, what do you have? So I know the equation for my x is, this is my equation for x. I'm just going to write it down. Cube. So when x is 0, I have t to the power 5 minus 4t. 4t to the power cube equals to 0. So it seems like I can factor out t cube. I have t squared minus 4 equals to 0. So I know that my solution of t is 0 and t equals to plus minus 2. Okay, similarly, my y equation is t squared. So when y equals to 4, I have t squared equals to 4. T will be plus minus 2. So now we have obtained two values of t. Okay, remember this is our derivative. dy dx. Okay, this is our derivative. Okay, let's look at, so all our points are the values of t. Not the value, I can do that. The values of t are t equals to 0, 2, and minus 2. So what happened when t equals to 0? Okay, let's just check. When t equals to 0, okay, what we get? dy dx equals to the equation that you have found from the derivative, which is 2 over 5. Look at what happened when t is 0. I'll get a term involving 2 over 0. So which is you cannot divide by 0 here. So we cannot consider t equals to 0. Okay, now, so I'm not going to consider t equals 0. So what happened when t equals to 2? dy dx equals to 2 over 5, 2 to the power cube minus 12 times 2. Okay, you're substituting at this equation, okay, when t is 2. So what do you get? 2 over 2 to the power 3 is 8. 8 times 5 is 40 minus 24. So which is 2 over 16, which is 1 over 8. Okay, that's good. Now when t equals to minus 2, I have dy dx equals to 2 over 5, 2 squared. Oh, yeah, minus 2 squared minus 12 minus 2. So I have 2 over 5 times 8, 40 plus 24, which is 2 over 64. Divide by 2, what do you get? 1 over 32. Okay, is that what you get? 1 over 32. I think there's an error here because this is a minus here. Power 3, not power 2. This is power 3. So negative 2 to the power is negative 40 plus 24. Yeah, that's much better. So this will be minus 16, which is minus 1 over 8. Okay, so what will be our equation at the line? So the first equation of the tangent line at t equals to 2. So y equals to mx plus c. Okay, so my y equals to m. This is our tangent. dy dx is my m. Okay, so which is 1 over 8 x. Now what is c here? So we know the point, the intersection point when x is 0. What do you get? Given the point 0, 4. So that's easy to see that this is 4. Okay, so that's our first equation. And then the second equation of the tangent line at t equals to minus 2. So we again with the same equation, we have y equals to mx plus c. Now c here, maybe if you forgot, c is where is the intersection. You call it intersection is what happened when you call it, what do you call it? I can't remember the term here, but when x is 0, that is c. Okay, that is c. So maybe we can just Google it quickly. So y equals to minus 1 over 8 plus 4. Okay, so let's quickly Google and see what you get. Tangent equation or equation of a tangent. Okay, so I want to see what you call that. Okay, so from here, what can you see? So some of the terms where y-intercept, that's what I want to call. Okay, the slope-intercept formula for the line y equals to mx plus b here, but in our case it's c, right? Where c that we're using is the y-intercept. Now y-intercept happen when x is 0. Okay, so in case you forget, this is our y-intercept when x is 0. Okay, that's the first example that involving tangent to the curve. Now there's also something called horizontal tangent that you need to understand. So I'm just going to write it horizontal tangent. For the parametric equation, the horizontal tangent happens when dy dt equals to 0, provided that dx dt not equal to 0. Okay, so dy dt equal to 0, and we can also have vertical tangent. Now vertical tangent happens at dx dt equals to 0. So I'm going to show you one example involving this horizontal and vertical tangent. Okay, so example to this, it'll be something like this. Okay, so the question say determine the xy coordinates of the points where the following parametric equation. Now, to be honest, I shouldn't mention parametric equation at all, because you know that if it's involving two equations x and y, that it is parametric equation. Okay, so we'll have horizontal or vertical tangent. Okay, so these are the equations. See, if you are given a two equation involving x, involving t, and y involving t, this is parametric equation. Okay, so first of all, it says that determine the x, y coordinate. So your answer must be in the form of x1, y1, x2, y2. Okay, where the following parametric equation will have horizontal, vertical tangent. Okay, it's not that complicated actually, because all we gotta do is to have horizontal tangent, we gotta find dy dt equals to 0. And then to find vertical tangent, we have to find dx dt equals to 0. Okay, let's look at this one first. Let's find what is dx dt. 3t squared minus 3, and dy dt equals to 6t. Okay, now to get the horizontal tangent, so first one is horizontal tangent, which is dy dt equals to 0. So we have 6t equals to 0. So we know that t is 0. Okay, so what are the points when t is 0? When t is 0, we can see that x equals to 0 cubed minus 3, 0, which is 0, and y equals to 3, 0 squared minus 9, which is minus 9. So the coordinate point, that's the first coordinate point. The coordinate point that the horizontal tangents occurs is at 0, negative 9. Okay, now the second one is the vertical tangent. Now vertical tangent happen at dx dt equals to 0. So we have 3t cubed, 3 squared minus 3. So 3t squared minus 3 equals to 0. Alright, do I have 3? Yeah, so how to do this? So let's simplify this. Equals to 3. T squared equals to 1. So t will be plus minus 1. Okay, so we have two at least. So we have when t equals to 1, x is 1 cubed minus 3, 1, which is 1 minus 3, you have minus 2. And then when the y will be 3, 1 squared minus 9. So 3 minus 9 minus 6. And then when t is 1, negative 1. So x will be negative 1 cubed minus 3 negative 1. That will be negative 1 plus 3, which is 2. And y will be 3 negative 1 squared minus 9, which is the same like what you will get above is minus 6. So the two vertical tangents, will occur at the points minus 2 minus 6 and 2 minus 6. Okay, so this is one simple example. Now you can actually sketch this graph. Okay, let's try to sketch this given graph like how we have done earlier video. Okay, so all you gotta do is, so we have t and then x and y here. Okay, obviously my t, I need to have negative t with the positive t. So I have 1 minus 1 and 0, right? So let's start with minus 2, minus 1, 0, 1, 2, 3, I don't know, 4, I don't know. Okay, let's do 3 first. Okay, the equation for x here that's given is this one. 3 cubed minus 3t. This is 3t squared minus 9. Okay, what do you get when t is minus 2? Minus 2 cubed. Okay, we have minus 2 cubed minus 3 minus 2. So we gotta work fast here, which is minus 8 minus 8. Let me just do it here. So when t is minus 2, we have minus 2 cubed minus 3 minus 2. So I have minus 8 plus 6, which is minus 2. Okay, my x is minus 2. When t is minus 2, x is minus 2. And y here is 3 minus 2 squared minus 9. So minus 2 squared is 4 minus 9. So 12 minus 9 is 3. Okay, now t is minus 1. So we have minus 1 cubed minus 3 minus 1. We have minus 1 plus 3, which is 2. When this is minus 1, we have 3 minus 1 squared minus 9. We have 3 minus 9, which is minus 6. Okay, when this is 0, this is 0. When this is 0, this is minus 9. When this is 1, we have 1 minus 3, minus 2. When this is 1, we have 3 minus 9, minus 6. Okay. And then what we have, 2. 2 cubed is 8. So we have 2 cubed minus 3 times 2. 8 minus 6, which is 2. And then for this part here, 2 squared minus 9. So we have 12 minus 9, which is 3. And then when this is 3, okay, so last point here. So 3 cubed is 27 minus 9. Okay, that will be 18. and it's way bigger number here. And then when this is 3 times 3 is 9 times 3, 27. 27 minus 9, which is also 18. Okay, I hope we don't have to consider the last point. I'm just gonna sketch it. So what we have here, if I have a graph of x and y, depends how big is my graph here. So I'm just going to consider until we can see that we have more negative value than positive value. So 0, -1, -2, -3, -4, -5, -6, up to -9. Okay, 6, -7, -8, -9, and then x positive is from -2. So we have -1, -2, 1, 2. Yeah, I'll just do 3. And we have 1, 2. Okay, so let's do this. When x is -2, y is 3. Yeah, this is 3. Okay, and then when x is 2, y is -6, all the way down here. And then we have when x is 0, y is -9, which is here. And then when x is -2, again, -6, which is here. And then we have when x is 2, y is 3. What's going on here? Just be careful with what we are drawing. Can't see the point. It seems like it's coming like this. What is and then okay, it looks like a shape something like this. But I don't know what is the intersection point here. We know that when this is 0, when t is 0, we get -9, which is here. So I think, I don't know, it seems like something like this. So I don't know whether this will be 0 or not. I'm not too sure what's the point here. This is 0, 0. So it should cut something like that. So this is not quite an accurate point here, because your graph should be something like this, okay? Something like this, right? This is maybe 0, 0 if you sketch them properly. Okay, so what we can say here, we know that when the coordinate point for the tangent, right? We have -2, -6, -2, -6. So we have this vertical tangent and -2, -6, and 2, -6. So these are my vertical tangent. See? These are the vertical tangent. These and this. And then my horizontal tangent happen at 0, -9, which is here. This is my horizontal tangent. So when t is 0, right? This is what you get. This is when t equals to 1. This is when t equals to -1. This is when t equals to 0. So this is what we can say about our sketch, and I hope you can do it properly. Okay, I guess I will end for today's class. So where you have looked into 3 things. So the first one is parametric equation. So you identify what are the parametric equation. And the second one, you have learned about tangent to the curve for this parametric equation. And the third one, we also learn about how to sketch the parametric equation and the equation, the curve involved, so such that horizontal and vertical tangent. Okay, bye for now, students.